Boa tarde. Bom, pessoal, vamos tentar começar aqui, quase dentro da nossa programação, às 2 horas, 14 horas. Então, antes de dar início ao painel propriamente dito, gostaria de agradecer a presença de todos no nosso painel de veículos elétricos e híbridos, do 28º Congresso e Mostra Internacionais da SE Brasil, Tecnologia da Mobilidade. O tema central do nosso painel será a eletrificação dos veículos no futuro da mobilidade sustentável. Eu tenho alguns avisos para vocês e eu gostaria inicialmente de pedir desculpas por um problema técnico. Não foi disponibilizada a tradução simultânea para esse painel. E nós teremos 2 apresentações que serão feitas em inglês, tá? Então, espero que vocês consigam acompanhar. O aplicativo do Congresso SAE Brasil 2019 já está disponível. Acredito que vocês já devem ter baixado esse aplicativo da sua loja de aplicativos, mas quem ainda não fez, pode fazê-lo agora, de forma que estejam aptos a fazer perguntas e avaliar o painel ao final. No aplicativo foi feita uma modificação que facilita aos participantes, à audiência, fazer as perguntas. Então, no menu principal, do lado esquerdo, na sequência do menu, tem a agenda e abaixo da agenda foi criado uma linha Faça uma pergunta. Então, você querendo fazer uma pergunta para os participantes desse painel, você clica nesse Faça uma pergunta, vai aparecer uma opção de 2 painéis lá, você clica no painel de veículos elétricos e híbridos, e aí já pode digitar a sua pergunta, que ela vai aparecer para mim aqui, e ao final do painel, nós então faremos uma rodada de perguntas e respostas. Também é importante que vocês baixem o aplicativo para poder fazer a pesquisa da avaliação do painel, que é muito importante para a SAE entender se o conteúdo foi legal, se atendeu às expectativas ou o que vocês esperam dos próximos congressos. Muito bem, vamos ao nosso painel, então. O tema não poderia ser mais atual, né? Veículos elétricos e híbridos, aos poucos, aqui no Brasil, se torna uma realidade. Nós tivemos recentemente uma montadora instalada aqui no Brasil que começou a produzir um sedã de grande volume na versão híbrida, né? O primeiro veículo produzido aqui no Brasil híbrido, e ainda com uma novidade, que o motor a combustão é o motor flex, que é a primeira vez no mundo que se faz lança um produto com essa tecnologia. Então, a gente vê que, talvez um pouco atrasado em relação a outros países, a introdução da eletrificação na mobilidade aqui é uma realidade. Já se fala, né? Ontem eu participei também no painel dos engenheiros-chefes, onde o tema era a mobilidade sustentável, mas não poderia deixar de abordar a eletrificação dos veículos, né? Conforme a maioria dos palestrantes de ontem, talvez alguns de vocês estivessem aqui ontem também, o veículo do futuro, além de ser autônomo, conectado, compartilhado, ele será elétrico também. Então, vamos ao nosso painel. Meu nome é Reinaldo Muratori, eu sou diretor de planejamento estratégico da HPE Automotores do Brasil, que aqui é a fabricante e comercializa os veículos da marca Mitsubishi e da marca Suzuki. Eu estou na indústria automobilística já há quase 40 anos, passei por diversas fases dessa indústria, mas me confesso ainda surpreso com as transformações e com a velocidade das transformações que estão ocorrendo recentemente, né? A gente vê que o ciclo de desenvolvimento de produto, que antigamente era muito extenso, hoje já não pode, porque você tem que prever um futuro que poucos sabem exatamente como vai ser. Mas é um desafio, e desafio é aquilo que move a engenharia. Então, nós estamos aqui agora para tratar especificamente de veículos elétricos e híbridos e, de certa forma, qual é a realidade dessa tecnologia para o nosso país. Bom, agradeço mais uma vez a presença de todos, vocês que estão aqui na audiência e principalmente também os nossos painelistas. Nós temos um um cenário onde a eletrificação, como eu já falei, é incipiente no nosso país, mas muitas montadoras e outras empresas que fazem parte desse ambiente, como as fornecedoras de energia, fornecedoras de carregadores e outras soluções para a mobilidade, estão muito interessadas e têm planos ambiciosos para esse mercado. Eu vou chamar aqui ao nosso palco para compor a mesa virtual, né, hoje não se usa mais a mesa, 3 palestrantes que vão nos honrar com suas palestras e são pessoas que estão diretamente ligadas no tema do nosso painel de hoje. Eu vou convidar em português, depois, para que vocês entendam, e vou fazer o call em inglês também, para que a pessoa possa se sentir mais à vontade. Primeira a ser chamada é a engenheira Maria de Odriozola Martínez, que é gerente de pesquisa e desenvolvimento de segurança passiva da Applus Idiada. Please, Maria. A Maria iniciou sua carreira na Applus Idiada como estagiária no Departamento de Segurança Passiva, enquanto finalizava seu mestrado em Engenharia Mecânica. Ela fez sua tese final sobre as diferenças de desempenho entre bonecos de teste de colisão do Eurocid 2 e do WorldCid. Depois tornou-se engenheira de projeto no Departamento de Segurança Passiva, onde se tornou especialista em biomecânica e simulação da Idiada, participando de uma ampla variedade de projetos de desenvolvimento de segurança passiva, com OEMs em todo o mundo. Ela é responsável pela análise de novas tendências e tecnologias, elaborando o roteiro de segurança passiva da empresa, identificando as necessidades futuras das montadoras, executando os projetos de pesquisa e desenvolvimento que levarão a essas metas. Antes de chamar o próximo palestrante, e aproveitando que tem mais um pessoal chegando, eu pediria que todos não se esqueçam de deixar seus celulares no modo silencioso. Agradeço antecipadamente. O segundo convidado é o engenheiro Roger Guilherme, gerente de engenharia da Volkswagen do Brasil. Por favor, Roger. O Roger é graduado em Engenharia Aeronáutica pelo ITA, pelo Instituto de Tecnologia Aeronáutica, e mestrado em Engenharia Automotiva pela Poli-USP. Atua há mais de 20 anos na engenharia de produto, sempre ligado a temas referentes a projetos e aplicações de motores e transmissões. Desde 2010, é gerente da área de pré-desenvolvimento de powertrain, que desenvolve principalmente trabalhos visando a melhoria da eficiência energética e a redução de emissão de CO2 dos produtos da marca Volkswagen. E como terceiro convidado, é o engenheiro Ryan Lasky, vice-presidente de engenharia de veículos comerciais da Dana. Please, Ryan. Ryan iniciou sua carreira na Dana Corporation em 2000 como engenheiro de aplicações. Em 2006 foi promovido a engenheiro-chefe, onde gerenciou equipes responsáveis pelos lançamentos de sistema de transmissão para vários clientes globais. Em 2011, Ryan assumiu o cargo de gerente sênior de engenharia de produto, onde gerenciou um departamento global responsável pelo projeto e desenvolvimento de componentes de eixo de transmissão para os mercados de veículos leves, pesados e fora de estrada. Mais recentemente, Ryan atuou como diretor de engenharia do produto, transmissões, cargo que ocupou por quase 2 anos, onde foi responsável pelo desenvolvimento de estratégias agressivas de produtos para eixos de transmissão. Ryan possui extensa experiência em engenharia de transmissão, com foco em inovação. É bacharel em engenharia mecânica pela Universidade de Toledo e mestre em administração de empresas pela Purdue. Bom, eu agradeço novamente a presença de todos, os painelistas e os profissionais que estão atendendo aqui na audiência. Pela segunda vez, peço que todos deixem seus celulares no modo silencioso. E vamos, então, para a primeira palestra. Eu vou chamar aqui a engenheira Maria de Odriozola Martínez, que abordará o tema Passive Safety Considerations for Hybrid and Electric Vehicles.
Thank you very much for the kind introduction, and thank you all for being here. Well, my name is Maria de Odriozola. I'm a Research and Development Manager in Applus Idiada in Spain, and today I'm going to talk about passive safety in hybrid and electric vehicles. So this will be the summary, the presentation contents of today's speech. So first of all, I'm going to go through global electric vehicle sales, specifications and safety risks of electric vehicles, some electric vehicle crash events that have been on the press, current crash test protocols for electric vehicles, and also additional proposals for electric vehicle validation. Finally, some research studies on electric vehicle safety and the conclusions. As you can see in this graph from the Global Electric Vehicle Outlook from 2019, electric vehicle and hybrid electric vehicle sales have been increasing during the last years. This trend is going to continue happening as expected in the forecast from now on. Excuse me. For electric vehicle, first of all, we'll look into the definition, types, and advantages. As definition, according to the energy.gov, they're vehicles that derive all or part of their power from electricity supplied by the electric grid are those classified as electric vehicles. We would have several types, excuse me again, several types that we would be considering. We would have battery electric vehicles or plug-in hybrid electric vehicles. Some of the advantages of these would be to reduce fuel costs, cut petroleum consumption, or reduce tailpipe emissions. As to passive safety specifications and risks for electric vehicle, of course, electric vehicles will have to fulfill normal crashworthiness standards as to structural behavior in the case of the crash and occupant protection. However, of course, electric vehicles have an added risk which is related to electrical vehicle safety. And this is what we're going to concentrate on in today's speech. So some of the electric vehicle safety risks that we would consider would be, for example, gas leakage, electrolyte leakage, thermal events, and electrical hazards. Of course, on the press, every time there is an electric vehicle accident with fire, it very rapidly goes on all media. All OEMs would like to avoid this, but of course also because of the risk that it may cause by being in the road. For these reasons, there are many crash test protocols currently related to electric vehicle. Here you can see an overall summary with the name of each of these different protocols worldwide. But we'll step through them one by one in the next following slides. For crash test protocols, we would have mostly frontal impact, side impact, and rear impact. And inside frontal impact, we would have 0 degrees full frontals, 30-degree frontal test, and frontal 40% offset deformable barrier test. Then we would have side MDB crash test, so that's mobile deformable barrier, trying to point for a car against car, and then rear impact. So in the case of full frontal crash tests, we would have that both in Europe and Japan, this test is done at 50 kilometers per hour, while in the United States and in China, it's done at 48. And the test is effectively just a car hitting a rigid wall in 0 degrees and full frontal. The test is also done in the case of the United States at 30 degrees, also to evaluate electric vehicle safety and the electrolyte spillage and event of fire after the crash. Similarly, for the frontal offset deformable barrier, which represents a car against car crash, the test would be done at 56 kilometers per hour. For side impact, we would have similarly a trolley going at 50 kilometers per hour that simulates a vehicle. And in the case of the United States, it is a cracked barrier at 54 kilometers per hour in fully laterally condition. Finally, in rear, we would have in Japan a rigid barrier at 50 kilometers per hour, and in the United States, a deformable barrier at 80 kilometers per hour. Excuse me. In China, this is still in progress, but they are considering adding another test for this. However, of course, we do need to consider additional proposals for electrical vehicle validation. The amount of tests that are included in protocols is restricted until now. As you've seen, all of the tests are pretty repetitive, and they only comply with a certain amount of crashes that actually happen in the road. One of the challenges that is to be considered is the risk of the battery penetration from underground. This is happening in the field. We've seen it several times. Some of the cases were shown in the images before, where something was in the road and the vehicle drove on top of it. By penetrating the battery, there was a thermal event in the battery. Some of these cases could be also something like an embedded rock in the road, jammed beams that are also found in the road, or simply by jacking the vehicle in the point where the battery may be critically softer. So considering this, as well as other hazards from electric vehicle, one of the tests that we consider for development and in-house testing would be to do the high voltage battery abuse testing. So in this case, what we would do is we would have the high voltage battery mounted on a trolley, and we would be impacting against something that could be on the road. In this case, it's the jacking ball or any other element that may be on the road. Other aspects that must be considered are actually in the battery case itself. It is important to evaluate in all of the points of the battery case and the battery as a whole if there may be any kind of ignition if the impact happens in a point that is not relative to an actual protocol. In this case, what we do is we do especially pole tests, as there is higher intrusion in these cases in different points of the battery, and in that way we try to ensure that the thermal events will not happen once the vehicle is in the field. On the other hand, we also do high voltage frontal impact tests only on the high voltage systems except the battery itself. With this, what we want to see is if when we accelerate the high voltage systems, if this creates any type of problem or with the high voltage disconnect systems of the vehicle. Many research studies have been done on electrical vehicle safety, and here you can see just some of them. Firstly, we will concentrate on the comparison of occupant protection in electric vehicles versus internal combustion vehicles that was presented recently by Suzanne Tilko from Transport Canada in the ERCOBI conference 2019. In this paper, the speaker wanted to check if occupant protection, that is to say, the different injuries that a person could sustain inside a vehicle when having a crash, were different when you had an internal combustion engine vehicle or an electric vehicle. Because safety concerns seem to be concentrated on the battery only, but of course the vehicle is changing by the fact that we have a high voltage battery. The structure is more rigid, then the pulse is more severe in case of a crash, there's a higher acceleration, restraint systems have to be different, and it is affecting a wide variety of aspects of passive safety as well as strictly the battery. In this paper specifically, you could see that overall in the different body regions that were studied in the paper, in general, internal combustion engine vehicles had higher values, so more risk of injury for occupants than electric vehicles, which was a surprise as nobody was expecting this change. However, as the restraint systems have been more advanced in the vehicles that they were being tested in this study, that is probably the difference that explains this deviation. On the other hand, there's also papers such as these two that I have highlighted here that have concentrated in other areas, such as, such as the actual causation of the thermal event and how it expands inside the battery. Actually, in the two images in the right, you can see how they're doing something similar to almost a drop of a rigid impactor and also a beam against the battery to see how this concentrates the thermal event in part of the battery and to see if it expands in a way that may be critical during a crash. As conclusions then, we would like to highlight that electric and hybrid vehicle sales are increasing rapidly worldwide, and they are doing so in all of the different markets at earlier or later stages. Additional crash safety risks must be considered when developing electric vehicles. We have seen this as not only do we have the normal crash safety risks as to occupant protection and vehicle structure, but also the risk of ignition or electrical hazards in the high voltage battery itself. Current electric vehicle safety protocols may not be sufficient to guarantee full high voltage battery safety. Because of this, during the development of electric vehicles or hybrid electric vehicles, it is important to carry out a full suite of development tests, including some of the suggestions that have been commented on before. High voltage battery has to be considered both as a component and as a subsystem before trying to include it in the full car in order to ensure avoiding thermal events. Finally, additional electric vehicle crash safety test modes have been proposed, such as the underground or ground strike protection, pole impact testing in the critical points of the battery case and the full battery, or additional crashes as could be a full-scale crash pole test, or etc. So with this, thank you very much for your kind attention, and we'll take any questions later on. Thank you.
Antes de passar a palavra para o terceiro e último palestrante do dia, eu queria lembrá-lo sobre as perguntas, tá? Assim que o Ryan terminar a apresentação dele, nós vamos iniciar a sessão de perguntas e respostas. Vai depender do tempo que a gente tiver após a última apresentação. Eu peço que vocês usem o aplicativo, né, o app do Congresso SAE Brasil 2019, para fazer suas perguntas. No menu principal existe uma linha lá, faça sua pergunta, clica lá, escolhe o painel elétricos e híbridos e faça sua pergunta. Ao final da última apresentação, nós faremos essa sessão aí, ok? E não esqueçam também de, ao final, usar o aplicativo para fazer a avaliação do nosso painel. Então, eu queria agora chamar o Ryan aqui ao púlpito para fazer a apresentação dele. O Ryan vai abordar o tema Future Electrification Powertrains in Commercial Vehicles. Ou seja, agora falamos da parte de segurança de veículos, falamos de uma montadora, qual a sua estratégia para veículos leves, e agora o Ryan vai poder falar um pouco sobre o uso de eletrificação nos veículos comerciais. Ryan, please.
Thank you. Thank you very much. Thank you for the warm welcome. And I'm very excited to be here today and share with you guys where Dana sees the electrification industry going, specifically around the commercial vehicle market. And I'll take you guys through some of the things that we've done in order to kind of reshape our business and some of the things that have driven us to do so. A lot of people talk about what is driving the electrification trends in the industry today. From a commercial vehicle standpoint, I think it's very clear. You have the local emissions and regulations that are coming up, which is basically the time that local regulators can make changes for their cities around the world. It doesn't require large legislation in an entire country or even globally. A local city official can decide they want to enforce emission-free zones, and in the process of doing that can really change how goods are transported in and out of those areas. The next item that I think a lot of people lose sight of is the green corporate image. And the Volkswagen representative took us through a lot of the things that they're looking at from a well-to-wheel standpoint. but it runs all the way down from an OE level all the way down to fleet customers. It's something that if Coca-Cola wants to show that they have a green corporate image and reach out to that customer base, they don't want to have big diesel trucks pulling in and out of the grocery stores to deliver goods. So it's something that change can come from a number of small individuals and is really what is starting to shift this market into the electrification trend that I think we see it in today. The other key piece with the transportation space is whether you're moving goods or whether you're moving people. Your job as an operation is to do it in the most efficient fashion. So as soon as the total cost of ownership starts to trigger into a point where it starts to save you money, you're going to start to see the demand. And a lot of the fleets and municipalities are seeing that today. We've been watching the price of batteries drop about 11% year over year for going on about 5 or 6 years now. And I think we expect to see those trends coming forward. We've already crossed over the total cost of ownership in some segments, and we're identifying some that we think are coming in the next couple of years. It's a decision that is completely different from you and I making a decision to drive a battery electric car. We can make that decision individually on our own desires and needs. But as soon as a fleet owner who's operating thousands of trucks can save a couple pennies per mile in delivery, they're going to make that change. So their change is going to happen rapidly. This is what we see from the forecast based on this information from a commercial vehicle standpoint globally. This kind of gives you kind of an insight of where the market sits today. The majority of EVs in commercial vehicle space today sits in the bus world, and the largest percentage of these are obviously sitting in China. You know, the subsidies that the government put in place there really drove the volume to the bus market, and a lot of the other areas are starting to follow. Now you're starting to see with most of the rest of the growth that starts to come in the coming years, that starts to come with the technology benefits that you see in the total cost of ownership trend. What we look at from a Dana standpoint is we don't think there's any single solution for any customer. We think there's going to be a number of different technologies that are going to win in this space. There's a number of different ways and configurations that can drive the fuel economy benefits and the savings. If you look at battery electric, there's 3 primary ways that we look at battery electric vehicles and the architectures that will live in those in the future. You have a central direct drive, so this is no gearing, just a large traction motor driving your traditional driveline and axle. You can insert a gearbox behind that to give you additional speed and power. And then you can ultimately move that motor into the axle position. And that can be centralized or it can be at the wheels, but somewhere in that axis. Each of these configurations offer its own benefits. Right now, if you look at the industry today, over 95% of the industry sits at that top line, that central drive, direct drive. And we expect that to be a solution that's going to win for a number of years to come because it's simple. It drops in the architectures of vehicles today in the same place that you would drop a transmission and an engine. So it's something that can be implemented very quickly. Also, when you get into the service distribution centers, it looks a lot like what people are used to working on. So it's not a scary technology for people to handle and to grasp. And that's an important aspect. It's one thing to put the vehicles out for its initial sale. It's another thing for these to be maintained for 10 years, 20 years to come. So that's an important aspect in what we have to deal with as we're looking through these systems. When you look into hybrids, there's basically 2 primary ways. You have the serial hybrid and the parallel hybrid. Serial hybrid is pretty much some sort of engine. The vehicle. In your parallel hybrid, you're going to be mixing power both from a traction motor and from your diesel engine. These have, I'll say, mixed feelings depending on who you talk to. Some people have very good experience with hybrid systems. Some people are nervous because you're adding a lot of content and a lot of complexity. So, but we're willing to support any that we see here. We think that there's no, like I said, no one solution meets all customer demands. I'm going to show you a little video here that is kind of how Dana has kind of seen ourselves when we started down this journey.
There's an old saying, If you always do what you've always done, you'll always get what you've always got. Some might see that as a negative, but what if what you've always done is find a better way and end up with a better result? A better way to convey power, eliminating sprockets and chains by inventing the encased universal joint, unchaining the automotive industry. A better way to engineer integrated powertrains, a better way to move vehicles forward. What if doing what you've always done means strategically placing yourself closer to customers around the world, or always finding better ways to efficiently transfer energy to the wheels for not only light vehicles, but commercial vehicles, off-highway equipment, and for off-road enthusiasts? What if doing what you've always done means fueling a high-performance culture with the best and brightest people?
So we're going to stop there. But I'll summarize it, since it didn't finish on its own, I'll summarize it myself. Dane is a company that's over 115 years old. Our company was based on transmitting torque from the front of the vehicle to the rear of the vehicle, and that's what started our company. And that scares a lot of people in our industry when you start to put motors in the back of axles, and all of a sudden you don't need some of the things that started our vision company. So what we did is we decided to take an aggressive approach about 5 years ago into how do we win in this space. We did is we made a series of acquisitions and partnerships to allow us to be competitive in this space and be on the forefront of what is going to happen in this electrification trend. And we may have gone a little early, but we think we positioned ourselves right at the precipice of when this is going to come in. First acquisition we made was TM4, a large traction motor supplier based out of China and Montreal. They currently are in production today with a number of traction motors supporting bus and commercial truck. The next step we identified is without having just a traction motor, the OE customers don't have solutions for the rest of the auxiliary systems. As soon as you start to pull off belts off of your diesel engine, all of the rest of the auxiliary systems need to be powered. So we went and acquired a company based out of Europe known as the SME Group. They have a series of induction motors that can support low voltage applications as well as high voltage applications for the likes of your steering systems and your AC compressors. We acquired Orlicon Drive Systems, a company known for its transmissions, known for its shifting capability. So we were able to bring in those controls competency to allow us to have the most integrated solutions as we start to move forward. We figured if it's good enough to design transmissions for the McLarens and Lamborghinis and Ferraris, they would look really good doing large commercial vehicle trucks and buses. We made an investment in a company called Hyliion. This is a little startup born out of Carnegie Mellon. And what they've developed is they developed software algorithms that allow them to predict the terrain coming ahead, and they can discharge batteries in order to optimize your diesel engine. So this can be a bolt-on system that you can drop in that gives you up to 25% fuel economy benefits. It can also run an APU and a sleeper cab. So as I said, there's a lot of different solutions. So this gives us that hybrid niche in a parallel hybrid arrangement. Our latest acquisition, just last month, we acquired a company called Nordressa. Nordressa is what we view as a traditional upfitter and integrator. And if you look around the industry today, electrification is coming so fast and so furious that a lot of the OEs can't react fast enough. So you have a number of startups that are out there today who are meeting this niche demand of architecting vehicles and providing full turnkey solutions. We felt that we needed to have that competency in-house to be able to go to our customers and offer that same solution. So a company that was founded on a universal joint and have supplied axles for hundreds of years now has had to make a series of investments here to position ourselves for the future. And that accounts for about $300 million of investment in the last 2 years to take a leadership position here. What we feel that does is it allows us to take fully advanced systems from the traditional names that have been known for years and starting to build them into more advanced systems. And then continuing to take those up and meet the demands of our customers, not just to provide them component solutions, but to provide them full systems, whether it be battery packs, whether it be vehicle architecture, whether it be accessory systems. we feel that we've put together a portfolio that can meet that need, because there's a lot of things that is new to the marketplace that we need to be ready to support, and we need somebody to help bring it all together as we do this and start to move down this journey. What we've built has now resulted in over 350 electrification-focused engineers, a patent portfolio over 500 now. It's probably closer to 600. And I think the most important thing that people want to see, especially when we meet with both OEs and fleets, is they want to see reliability. They want to see a company that knows how to deal with the commercial vehicle space, knows how to support aftermarket, knows how to support their customers. And we can do that with over 15,750 vehicles on the road today running our propulsion systems. We are just about, I think the end of this month, we're about to tip over the 1 billion kilometers driven on our propulsion systems. So these are not PowerPoint slides, these are not rapid prototypes, these are real systems running around the world today, which is giving us the ability to make modifications and learn things from them and continually evolving to be even better and better. This gives us a snapshot of just the portfolio that we've built. I'm not going to belabor you guys with a ton of details on this, but just to kind of give you a snapshot of the things that we've put together. You have things like propulsion systems, direct drive units, a number of them ranging from basically class probably 3 through class 8. We have generators, we have direct drives, and a number of different variants here. Inverters for both low voltage, high voltage, as well as inverters implemented into chargers. So a number of different components that we can supply in all the auxiliary systems. When you get into the auxiliary systems, we have systems today on the road throughout Europe for electric, hydraulic, assist, power steering. These are systems you can bolt onto diesels to reduce your drag on the diesel systems today just for fuel economy benefits, or they're the same systems that you're going to need once you start to peel back all of the systems that are driven by your traditional diesels, as well as a series of e-axles. We focused most of our attention, as I started on that market slide. We thought the first place to trigger was going to be the city bus, the transit bus market. So we have a series of e-axles. At least one of these is in production today. The other two are coming into production next year. And the other one is, I think, the year after. So a series of e-axle solutions that'll be out there. These are currently produced in China. Obviously, that's where the largest market is today. However, we can supply it anywhere in the world. The next area we focused on was light commercial van and medium-duty short-range delivery. So again, the ES4500i, this product launched into production in 2013. The 9000R, this one launches into production in Q1, as well as the 6200R. So a series of products that we have that are ready for production. Again, not prototypes. These are on bench tests today. These are in customer vehicles today, running fleet trials to start to see what the true benefits are. Again, this is something, especially when you get into managing the battery systems. Thermal management is a critical aspect to make sure, one, you can safely operate these vehicles, and two, you can keep your batteries running in the most efficient state. We've been in the battery cooling industry for going on probably 8 years now. We were in the early phases of helping General Motors fix some of their issues on the Volt program. And year to date, we've actually supplied 25 million battery chiller plates on those programs, and one of the customers told me is never forget to tell people that's with 0 ppm and 0 warranty in that entire time. So it's a very impressive feat on maintaining the systems in a way that can keep you running efficiently and safely. Now, as we've started to acquire battery competencies, we now have the ability to provide customized packs for battery electric. We can also provide customized packs for hybrid technologies. So both a power and an energy battery solutions. Right now we run with an NMC, but we can also do it in an LFP, and we're looking at some other chemistries as well. We're working today with companies who are doing solid-state battery work as well. One of our joint venture partners is one of the leading battery researchers in Canada. With the Nordressa allows us to provide turnkey solutions to our customers. So that can be anywhere from just power electronics cradles, it can be full vehicle systems, it can be driver interfaces with over-the-air updates, fleet management software, and for our customers we can provide both demonstrator vehicles. If needed, we can also help them with low-volume production. As I said, fleet customers are demanding this, and sometimes we're trying to find how do we manage all of the different priorities that any OE has right now. The OEs are managing safety priorities, the connected platforms, the electrification trends, autonomous driving. There's a lot of things to be managed. So if we can step in and take some of those things off their plate, we can kind of help them introduce this technology into the market. I kind of want to finish on one last item here, and it kind of gets into that full circle back to that architecture, and there's no one solution. Kind of give you guys an example of 2 vehicle demonstrators that we've put together with some OE partnerships. In both cases, we went from what was a central drive architecture with a large central motor and then transitioned it into an E-axle. The first one that we did was a workhorse van. It's like a UPS delivery truck in the Class 5 range. In this configuration, we moved from someone else's central mounted motor into a TM4 Dana E-axle. In that process of doing that, we reduced 176 kilograms of weight out of the vehicle and reduced the energy consumption by 8%. So that 176 kilograms, that can either be, additional freight capacity that we can leave with the customers, or it can be additional batteries that we can put onto the truck to get extended range. And so we repeated the same process with an Isuzu program. I think we showed this vehicle at the ACT Expo in Los Angeles this past spring. And in this vehicle, we moved from a Dana TM4 central motor, Sumo MD, into an E-axle. And in that process, we were able to eliminate about 2.5%, or improve the system efficiency by about 2.5%, which makes sense if you eliminate the axle. That's typically what most single axles are running at, is somewhere in the 96 to 98% fuel efficiency. So by putting it into a single drive, we were able to get that out. And we're over 100 kilograms of weight reduction. We haven't got the final weight on it, but when we start to add up the subsystems, it's probably closer to 150. But I didn't have the exact vehicle weight, so I kind of roughed it there. This is just kind of a snapshot of other programs that we've done. We've announced all of these at different shows and different units around the world. But again, it gives us the ability and the breadth to kind of show, because it was something that if we rewound 2 or 3 years ago when we started down this journey, we didn't really see ourselves having to offer full service vehicle integration, but it's something that the demand has kind of come, and we had to step up with a solution in order to really push this trend going forward. So I think it's an extremely important topic. I think everybody from an environmental standpoint knows that we need to do this, and we need to do it in the most cost-efficient way, and hopefully we've brought together a portfolio of products that will allow us to support that trend as we go forward. Thank you.
Thank you very much, Ryan. Nós tivemos então a oportunidade de assistir a 3 apresentações sobre o mesmo tema, porém com enfoques totalmente diferentes, né? Pudemos entender dentro de uma montadora de veículos leves, predominantemente leves, pelo menos na abordagem do Roger, qual é a direção que eles querem dar para a eletrificação, não só aqui no Brasil, mas em termos mundiais. E eu até fiquei um pouco surpreso com a informação que ele nos deu de que a Volkswagen está verticalizando a produção de componentes essenciais para um veículo elétrico, né? Como é o caso de motores e baterias. Eu não tinha ouvido falar disso. Eu sei de várias montadoras que têm parcerias com fabricantes de componentes elétricos para compor os seus produtos. Mas pela primeira vez eu ouvi de uma montadora que eles tendem a pegar aqueles componentes que são os mais importantes, né, talvez o core do veículo elétrico, e internalizar. Já na apresentação do Ryan, a gente percebe um fornecedor, um Tier 1, que é tradicional fornecedor para a linha de veículos comerciais no mundo inteiro, que percebeu rapidamente uma mudança nas direções e está com uma política bastante clara de compra de startups e outras empresas menores que já estavam desenvolvidas nesse meio, podendo dessa forma estar apto a oferecer aos seus clientes soluções praticamente completas de powertrain eletrificados. E na primeira apresentação da Maria, a gente pôde ver que não é somente do desenvolvimento do produto e da performance dinâmica desse produto, de autonomia, que o mundo se preocupa, né? Existe uma preocupação muito grande com relação à segurança desses veículos, principalmente quando a gente fala em baterias de lítio, né? Onde é bastante comum. Ela mostrou alguns casos da mídia noticiando problemas com veículos elétricos, acidentes, com incêndio, etc. Mas se a gente pensar no nosso mundo do dia a dia, né, o celular que a gente carrega no bolso, quantos casos a gente já não ouviu de baterias de íon de lítio que explodem, que pegam fogo, até mesmo em aviação, né? Um dos aviões mais modernos da Boeing ficou parado há algum tempo também por conta de problemas nas suas baterias de íon de lítio. Então, a segurança é uma coisa muito inerente ao produto, né? E até achei interessante que o Roger ele comentou na apresentação dele que o primeiro carro da Volkswagen elétrico era um Golf elétrico, que, como ele mesmo disse, era uma adaptação de um carro feito por um motor a combustão para um powertrain elétrico. Então, mas na questão de segurança, muita coisa muda. Então, não é simplesmente você pegar um carro, botar um motor elétrico e está tudo resolvido. Enfim, acho que a gente conseguiu ter uma visão bastante abrangente do assunto. Agradeço realmente a todos pelas palestras. Nós temos aqui cerca de 10 minutos para uma sessão de perguntas e respostas. Então, eu vou dirigir pelo menos uma pergunta para cada um dos palestrantes e peço desculpas às outras perguntas que não puderem ser respondidas. Eu vou tentar conciliar algumas em uma única, para que eles tenham oportunidade de falar um pouco ainda sobre o tema. First question is to Ryan. Okay, we will start the question and answer session. You have not so many time, so I will address one question for each one, and if you have time later, we can go ahead. Ryan, how do you see development of electric vehicles, commercial vehicles in developing countries? Because you mentioned a lot of developments around the world, but specifically in developing countries like Brazil and other similar countries, how do you see it?
Susan? I think the regulations that you see coming, I think, can come quickly. I think the developing countries are lagging a little bit on, say, more of the Western-style countries. So, but it is something that does change very rapidly. I know in India, it was just it was within the last year that they've gone from a very mild energy policy to a very aggressive policy when it comes to zero emission zones. And that's really started to change that demand. So it can change very quickly. And that's kind of where I was highlighting the point of the change can come from just small local regulations. It doesn't have to be worldwide. So that is one thing that we're seeing.
Thank you. This is to Maria. How you and your company support development of safety of electric vehicles? How do you see the evolution of destes to better support the safety improvements of these vehicles? And also, is there a software of simulation for safety analysis on the case of electric vehicles?
It's working? Yeah. So yeah, in our case, in Applus Idiada, we perform worldwide. We can do simulation. So we would do simulation of a crash test environment, but we would also be looking at the battery case, for example, and then you can also look at thermal events through simulation. Of course, the protocols are changing very rapidly. However, initially, most protocols worldwide, what they're doing is adapt current crash test protocols to include requirements for the high voltage system, so as to to make sure that there's no short circuit after the test, looking at temperature, looking at spillage or leakage of electrolyte and things like that. But they are not really creating any crash tests that are specific to electric or hybrid vehicles. That is why internally in Idiada we are helping our customers during the development phase in trying to define further tests such as those that I showed earlier, but also a wider variety of component and subsystem tests that are designed initially just to improve the crashworthiness of the battery, so how much it resists an impact or an acceleration, and to avoid having any thermal or electric events later on in the field.
Thank you. Para o Roger, vou juntar duas perguntas aqui que têm alguma similaridade. Uma tem a ver com a produção de energia elétrica e outro com as baterias. Roger, a produção de energia elétrica brasileira vai aguentar a evolução ao longo dos anos do uso de veículos elétricos? Vocês estão conversando com o governo a respeito disso ou não é uma preocupação? E a pergunta seguinte, queria que você respondesse as duas. Como a Volkswagen enxerga a evolução da tecnologia de baterias para aplicações em larga escala, considerando a escassez de materiais no longo prazo? Ou isso também não é uma preocupação?
A primeira, estamos falando do mercado brasileiro, a primeira pergunta da rede elétrica.
Na verdade, ele está preocupado se a capacidade de geração de energia do Brasil vai conseguir acompanhar a evolução do uso.
A resposta para a primeira, Reinaldo, é não. Nós não estamos preocupados com isso, ou seja, obviamente a gente pensou nesse item também, mas pequenas avaliações pelo volume que a gente espera de veículos elétricos no Brasil nas próximas, no final dessa década, na próxima, não é suficiente, na nossa opinião, para incomodar a nossa rede elétrica. Isso não está na prioridade de preocupações. Se vocês quiserem, qualquer um pode fazer esse tipo de conta. Pega aí 4% do mercado, se for elétrico, por exemplo, 5% do mercado que seja, se for elétrico lá em 2027, 2030, e tenta ver aí a quantidade de energia que a gente vai precisar para rodar o carro todo dia. Vocês vão ver que dentro da disponibilidade de produção brasileira, isso é muito pequenininho.
Isso é um problema.
Então, esse problema pode aparecer, mas mais para o futuro. Agora não seria uma preocupação. A segunda pergunta, sim, essa sim é uma preocupação do momento. Foi o que eu tentei falar lá. Não sou nenhum especialista no assunto bateria. A bateria só é, para quem trabalha na área de powertrain, um incômodo. Ou seja, dado que se quer que a estratégia da empresa é a eletrificação em massa, ou seja, é a popularização do veículo elétrico, tem que sim ser levado em consideração produção em larga escala, alto volume. E alto volume significa se preocupar com a escassez de material. Sim. Então, foi o que eu mostrei nos slides lá, o que a empresa está fazendo na Europa, por conta das baterias de híbrido, internalizando a produção das células, para tomar conta direitinho de cada etapa do processo, e indo, em termos de pesquisas, tentando ampliar a sustentabilidade dessas baterias, em 3 sentidos. Materiais, o tipo de material utilizado, pesquisar novos materiais, a extensão do uso da bateria, ou seja, fazer a bateria durar mais tempo e ter várias vidas, né? E as tecnologias de reciclagem dos materiais que estão e reutilização dos materiais que estão dentro das baterias. São só as 3 linhas de pesquisa.
Quer dizer, a parte de reciclagem, que hoje em alguns países é bastante importante já nos veículos a combustão, mas não na maioria dos países, no caso dos elétricos, deve ser uma questão bastante estratégica, né? Eu vou aproveitar ainda mais um minuto aqui, só para fazer uma última pergunta para o Ryan. Ryan, do you believe fuel cells will be able to compete with the batteries, with the electric vehicles, conventional electric vehicles? Fuel cells. Yes. If they will be competitive against the electric motors, electric vehicles, sorry.
I think the biggest challenge with fuel cells is the infrastructure that's going to be required in order to take fuel cells to the next level. We've been producing bipolar plates, which are basically the stacks that allows the electrons to move within the fuel cells. We've been doing those for a number of years. The challenge with mass adoption is the amount of infrastructure. We saw just a graph earlier of where the charging stations sit in Brazil, and we track that around the world and where electrical charging stations can go and where your grids are able to support those. That's already based on electric power being in all of those areas. So when you have to start to build an entire infrastructure for hydrogen, it's a challenge. So I think that's the biggest challenge with fuel cells.
Thank you. Agora eu prometo que vai ser a última, aproveitando a pergunta sobre fuel cells, células de combustível. I'd like to ask Maria about if there are or there is some protocol to test hybrid fuel cell vehicles, because the technology is a different one, and probably the risks are also different.
So, well, officially there is a bit of a lack of specification in that area. However, in general, all OEMs are looking into trying to do like the most severe crash tests of each of the different tests that are done worldwide. So this happens, like, I don't know, we've done several type of crash test programs back in our laboratory, and you do see that even if the OEM does not intend to sell into a specific market, they are using like the highest speed rear impact test or the most severe impact location, depending on where each of those alternative fuel cells where it can be worse, let's say, for those cases. So it is a bit of currently a bit of a like diffuse zone, but everybody's just looking for worst case scenario, which will cover all possibilities.
Which probably the major risk will be on the fuel stations, not
Yeah.
on the cars itself. Okay, thank you very much for Maria, Ryan. Obrigado, Roger. Se vocês quiserem fazer alguma consideração final, Roger, não sei. Maria and Ryan, if you want to make some additional comment before we leave. Otherwise, I would like to thank you very much for your presence, for your time, and also for the... Pois não. Pode. Deve.
Eu quero aproveitar todo esse pessoal que está aqui agora para vir participar do painel internacional que vai começar às 16 horas. No painel nós vamos ter vários palestrantes internacionais que vão estar falando sobre a inflexão da mobilidade que nós estamos passando nesse momento. Então esse era um recadinho rápido para que vocês possam aproveitar o próximo painel. Obrigado.
Obrigado, doutor. Obrigado a você. Na verdade, era a minha última fala, mas foi melhor porque ele está mais a par do painel. Então é isso, pessoal. Mas, de qualquer forma, mesmo para quem vai presenciar o próximo painel, eu peço que saia da sala para poder o pessoal preparar o ambiente aqui. Tem algumas modificações para o painel internacional. E, na sequência, às 16 horas, então começa o painel internacional, que é o último painel temático do nosso Congresso 2019. Obrigado a todos. Thank you very much.